All right, lab 5. We're skipping lab 4 because of lovely technical issues. All right, it is absolutely vital you understand pointers, so we're going to do another pointer exercise, right? Hopefully these two will finally get pointers down pat, but I doubt it. And that's okay. That's nothing against y'all, just pointers are very subtle. All right. Yes, both those things. Note, when a question asks for the value of a variable, if it is a known number, write the number. If it's a memory address, write it's a memory what the memory address is pointing to, aka variable x holds the memory address of variable y. So if it's a pointer, that's how I want you to answer. If it cannot be determined, say x's value is undefined or just undefined. All right. So here's a piece of code, x32, y is going to point to it, z is going to equal the dereference of y, and then print out. So what's the output? All right, hopefully y'all can figure that out. What's the value of y? Hey, look, y is a pointer. I just told you how to answer that one. And then what memory do the variables x, y, and z exist during runtime? Are they in the static, the stack, or the heap? All right. Then we have this code. What's the output? And yeah, I understand most of y'all are going to just print it. Compile and run it. I'm actually going to be okay with that for now. Where static, stack, or heap do the variables x and z exist? And why is this code bad practice, even though it compiles and runs without segfault? So why is it bad practice to do it this way? I have to let you think about what the problem is with this code. All right, again, here's some code. Create 100 integers, set one of them, set z here, and then print out z. What's the output? And here's a big hint. If you run and compile it, it's not going to give you the right answer. In what memory do the variables x and z exist during runtime? And then what is stored on the heap? I should give you a hint about what the answers are to be. And what is the memory issue here? How are we doing so far? No. Okay. And then we have this piece of code. Y is the output, y sub 10 equal 20. Well, we're creating 100 integers, setting y to a certain place, setting x's, and then printing off y. And y is y sub 10 equal to 20. Then write a line of code that would free up memory using only x, and then write a line of code that free up memory using only y. Remember that there's two different types of delete. There's a regular delete and the delete with the solid brackets. So make sure you know which ones to use when. Hey, look, another one. 100 integers. Hey, it's null. Uh-oh. I don't know if y'all seen this. So what is z? I'm going to help y'all out. What is z? All right, I'll get you started. It's a pointer. And what is it holding the memory address of? I think someone said it. A pointer. So it's a pointer holding the memory address of a pointer, which holds the memory address of an integer. So it's a double pointer. If I added another star, it'd be a triple pointer. All right. So we set x and y. We set z equal to the address of x. Why is that legal? Well, x is a pointer, so we're generating the address of a pointer and then storing it inside of z. And then we're going to print off something with z, and then set z again and print off again. Okay. What's the value of x and y? What is the value of z? On lines 14 and 16, there's 14, you can see it over there, and 16 right there. Well, what does this code fragment mean? I'm going to want you to describe what the code must do in order to execute that fragment right there. Think about exactly how it's going about it. Remember the parentheses, what happens in the parentheses happens first. There are two different outputs for 10. Here's the output of the program. No, why are the different ones? Whew, I thought for a second I didn't ask a question. Whew. Why are there two different outputs? And then write the commands to free memory. All right, lastly, here we go. I create a student object, has an ID and a GPA. I create 100 students, and then, ooh, what does this do? Well, let's start. What's student's PTR?
Double pointer.
It's a double pointer. And I'm setting it to new student. So I'm setting it to new, what's that?
It's a pointer to new student.
Ah, good guess. It's an array of 100 with 100 elements where each element is a student pointer. All right, so it's an array of 100 student pointers. So right here, just know that this is going to create a random GPA and assign assign an ID, and then it's going to set up your student pointers to point to the correct student. I'm going to run bubble sort. You don't need to know about bubble sort. You can look at it if you want to. Except for, what's the big O of this bubble sort? If instead of 100 we had n. So I'm saying that if this 100 was in and that 100 was in, what would be the big O of bubble sort? It'd be n squared. And then I print off the pointers. All right. What's the value of students? What's the value of students' pointer? Hey, we answered that question. Wasn't that nice of us? Which of the above is being sorted? Oh, I wonder if I told you that. No, I just said running bubble sort. Perfect. So what of these two is being sorted? Write the code to sort students without nesting for loops. Ooh, a little extra S there. In other words, I want a big O of one solution. So you're allowed to have two for loops as long as they are nested in order to solve this one. I'm going to warn you right now, I don't expect everyone to get D. That's just an expectation. D is going to be a very hard problem for some of y'all. So if you don't get that one, you get the rest. It's okay, that's fine. It is a hard problem, but it is going to make you think very thoroughly about how pointers work. All right? And then write the commands to free memory. Turn in via GitHub. It's due a week from today. Any questions? And good, we have just 5 minutes over lab time. Next class, we'll go over lab GNU plot real fast to clean that up and get that going, get that lab, and I'll also assign the project then. And then we'll go on to the next step, which should be basic arrays. So next class will be a little busy, but we actually went through almost 2 sections of material. We just had some last minute problems. All right, any questions?
For submitting this is a PDF, but
You can write it in a text document if you want
you
to.
can create a text document.
Yeah,
and
sure.
Submit.
Mhm.
Okay.
Sure, that's fine.
I'm just checking that.
Yeah. Or you can, well, you can add the PDF if you want to, but I recommend a text document. Okay.
Sounds like a reasonable suggestion.
I will have to cancel class a little early. I think it's 10:40, but I need to go look up. The reason for that is they're making all faculty members line up in their cap and gown and have a special chapel today, and they told me to cancel class early. So I guess you just don't get as much lab time, sorry. But please ask me questions as much as you can, and I'll go ahead and stop it here.